Good morning, good evening, everyone. So today is the fourth organized in University of Peradeniya and RMIT University together with the Joint Research and Demonstration Center for Water Technology. So we had very successful consecutive webinars, and now we are moving to the fourth webinar, and we got very exciting day today, and we are hoping to get very renowned tourist scientists from the environment coming from the so webinar is on industrial water and wastewater management challenges and solutions, and we are going to have the specific topic today that's on cleaner production and zero liquid discharge concepts for industry. So this is going to be very exciting day for us, and as I said, so this is organized by Joint Research and Demonstration Center for Water Technology under the Ministry of Water Supply, together with University of Peradeniya and RMIT University, Australia. So before getting into the webinar, I would like to remind you a couple of points here to make it a successful day for us. So please mute your microphones as well as turn off your videos. And if you have any sort of questions, you please get through the chat box or the Q&A section. That's the most effective way for us to communicate throughout the way of the seminar. So, and especially our panelists will be very much responsible to get to the all clarifications. So if anything we miss today, we'll be contacting you soon as possible. So I wish you to have a very fruitful day today with our very renowned panelists and the presenters. So I would like to invite to enjoy the video production to introduction to JRDC.
In year 2018, September 28th, Joint Research and Demonstration Center for Water Technology, JRDC, started construction, marking the official approval for the establishment of Joint Center for Water and Technology Research and Demonstration.
The China-Sri Lanka Joint Research and Demonstration Center for Water Technology has come into effect after signing of a MOU between both countries in year 2015. I believe that both Chinese party as well as Sri Lankan party has worked hard to understand the special objectives of this project and come to an agreement which can lead for smooth project execution.
Sri Lanka project team consists of Ministry of Water Supply, Ministry of Health, National Water Supply and Drainage Board, NWSDB, and experts from the University of Peradeniya. It formed a cooperation scheme to integrate resources from the governmental agencies, enterprises, universities, and research institutes of both countries, and explored a cooperation model of human capacity building, cooperation development of technologies, implementation of solutions by enterprises. The cooperation team covers interdisciplinary high-level experts from different cooperations, proficient in water sciences, geology, medical sciences, and public health.
Strengthening our historical relationship between China and Sri Lanka. This time the Chinese government has come forward to help us in establishing a research and demonstration laboratory in Peradeniya.
As a result, we have now initiated this several MOUs we have signed.
I feel JRDC will be a door for us to connect east and west of the world. So we want to make Sri Lanka is in a very important position in Indian Ocean.
I think Sri Lanka and China collaboration is lifetime.
From shore to shore, it seems, wide at high tide, before fair wind a single sail is lifting, Sri Lanka Joint Research and Demonstration Center for Water Technology aims to be a global partner in water, environment, and health research, offering a platform to promote North-South and South-South dialogue and a good model of science and technology cooperation under the Belt and Road Initiative. JRDC consists of high-technology analytical facilities, covering water, environment, and health-related aspects. The Volatile Organic Laboratory is mainly dedicated for volatile pesticides, disinfection byproducts as well and other volatile organic residues. Inorganic Laboratory is mainly dedicated for heavy metals, anion, and cation analysis. Non-volatile Organic Laboratory is capable of analyzing organic pesticides and residuals. Moreover, there is a laboratory for the biological parameter analysis. Not only that, but also JRDC have a high-technology conference facilities as well as accommodations for researchers. We cordially invite you to join with us. Make water clean and sweet.
So thank you very much. And we are now to begin our webinar. And before getting into the webinar, I would like to introduce our moderator for the day. So as I said, this is going to be the fourth webinar out of the series having 5 webinars. And today we are going to talk about the cleaner production and zero liquid discharge concepts for industry. So this is going to be a very exciting topic for us because it's very much timely important topic as well. So I'm happy to introduce our moderator of the event today. It's Professor DGGP Karnatha. So Professor Karnatha is a professor of chemical and process engineering, Faculty of Engineering, University of Peradeniya. He received his bachelor degree from the University of Peradeniya in 1992, and he has majored in chemical engineering combined with mechanical engineering. So he will be one of the best person coming from Sri Lanka as well as in the region to discuss about this topic. So he has received his PhD from University of Nova Portugal in 1999. So he has joined University of Peradeniya in 1994, and he got his professorship in 2018. So he is himself representing a lot of expert panels, and he has majored his subject area, especially under the research focuses on synthesis of value-added products from Sri Lanka mineral, air pollution, and health impacts, as well as gasification and pyrolysis. So Professor Karunaratne having a lot of publications done under himself, and he has then thereafter he has more than 2 decades of experience in teaching and supporting industries in areas of cleaner production, environmental management, and health and safety. So I'm very much sure that Professor Karunaratne will get us a very exciting day today. And it's over to you, Professor Karunaratne.
Thank you very much, Dr. Vegoda. Good morning and good afternoon, good evening, depending on from where you are joining with us. So again, I must thank the organizers of this webinar for giving me the opportunity to moderate this session because I think it's a very timely topic actually that we are going to cover today, which is on cleaner production and zero discharge of liquid concept for industry. Now, the question is why actually this topic? Why cleaner production and why we are focusing on water? Okay, so if you take actually, we call our planet as the blue planet, but unfortunately, out of this entire water content in the world, only something like 3% of the water is only fresh water. And out of that also something like 2/3 is actually frozen as glaciers, or otherwise that part is not available for us to use. Okay, so as a result of this population growth and also high use of this water, by 2025, maybe something like 2/3 of the world's population may face water shortage and also can affect ecosystem around the world very much because of the water shortages and so on. So that means now, not only for water, but also for other resources, we have this problem of overconsumption of resources. So that means now for industry, just meeting these compliance requirements through end-of-pipe treatment method is not sufficient, because end-of-pipe treatment method do not address the resource consumption. So as you know, cleaner production is actually a pollution prevention approach. So you need to have these kind of approaches to prevent the overconsumption, and then also to move towards circular economy or circularity in terms of resource consumption and recycling of the material that we use. Now, I'm sure most of you are familiar with cleaner production. I just take one slide to introduce the concept of cleaner production. So as you know, cleaner production is termed as like the integrated preventive environmental strategy. You can apply it to industry, processes, or product. So they are basically, our aim is to reach the higher positions in the waste management hierarchy. Our first focus will be to prevent waste generation, or if you cannot do it, at least try to prevent part of it or reduce, and then reuse, recycle. And finally, there may be something you have to dispose, so treat it properly and dispose. So for these, we use what are called these cleaner production techniques that basically address the root cause of waste generation through maybe product modification, technology modification, good housekeeping, better process control, and then input substitution, equipment modification, on-site recovery, or production of a useful byproduct. So in cleaner production, our focus will be basically on material, which is raw material and other material, basically after even the product waste generation, energy usage, water. So basically, we apply these cleaner production techniques and try to prevent the material wastage, energy wastage, and water wastage. So in today's webinar, our focus will be water. Okay, so we will move on to our first presentation, so which is done by Dr. Abhijit Date. So Dr. Abhijit is an associate professor in mechanical and automotive engineering, School of Engineering, RMIT University, Australia. He earned his bachelor's degree in mechanical engineering from the University of Mumbai and his PhD from the RMIT University, Australia. So his areas of expertise include heat transfer, thermodynamics, renewable energy, and then also solar PV and solar thermal system. Okay, so he's involved in many research collaborations with international industry and academia, such as Fujikura, Japan, MWH Global, Australia, Green Earth Energy, Australia, Pyramid Salt, Australia, and so on. So he has published more than 70 peer-reviewed journal articles to date since 2012. And he has supervised more than 10 PhDs and 2 master's students. So I now cordially invite Professor Date to deliver his presentation today. Thank you.
Thank you very much, Professor Karunaratne, for your kind introduction. And thank you very much for the organizers to invite me for making this presentation. I hope everyone can hear me. I'm now going to share my screen with you. I hope everyone can see my screen. So as introduced by Professor Karunaratne, my presentation topic is going to be on sustainable desalination or water treatment with focus on solar energy and zero to low liquid discharge. So, today's talk, we will mainly focus on about how to achieve sustainable zero liquid discharge. Okay, I will share some ideas that will help steer the interest in this area, and also maybe encourage some discussion in this area towards the end of this session. So I will share some of the research projects on the way that have been done at RMIT and the experience along with it. Now, maybe some of the slides which during my presentations they might sound like very conceptual, but the ideas are quite practical. So if you think a little into the idea, you would see the proposed concepts or proposed ideas are quite practical. Now, you might even ask while during my presentation to yourself, if the ideas are quite simple and practical, why they haven't been applied so far? And maybe in the discussion, we might be able to answer those questions. So let's first start with some statistics on water withdrawal. Professor Karunaratne has already explained the importance why, and the question why we want to discuss all these topics, why they're of current interest. So here's a graph which basically shows a snapshot of water withdrawal since 1901 until 2014, and at present, by 2019, the total, the overall global water withdrawal was way more than this particular 4 trillion. So 2019, it was close to 9 trillion cubic meters per year water withdrawal. So water withdrawal has been increasing quite significantly. Then let's look at different sectors that mainly withdraw water. So agriculture is one of them, and is the major withdrawal, is one of the major withdrawal sectors around the world. I've got some data on agricultural withdrawal for comparison between Australia and Sri Lanka, which I thought maybe would be very useful for today's presentation. So you can see, although I don't have data beyond 2005, but this is just to give you an idea. So it's close to somewhere between 10 to 12 billion cubic meters every year water withdrawal up to 2015. Beyond that, definitely has increased. Then for industrial water withdrawal, so that's what the global outlook looks like. And again, for Sri Lanka and Australia has been increasing, and the trend is can be considered to be going in the same direction, so that it's going to be increasing in the future as well. Similarly, the water withdrawal for municipal or domestic use, you can see that is also increasing. With Australia, there was a big drought around 2010, and there were a lot of water restrictions put forward by the government, a lot of state governments and water bodies, and that you can see in that range between, in those 10 years, 2000 to 2010, due to the drought conditions, the water withdrawal has dropped. But then since then, it's again started picking up. And while there is plentiful of water, human tendencies to just use it. So what this brings us to a big question. I mean, at present, more than ever, world is facing a big challenge of water crisis and wastewater management. So the question is that is the part of the solution within this particular problem, the problem being scarcity of water, increasing water demand, wastewater generation, and its environmental impact. So we believe the part of the solution is within here, which is efficient and effective treatment of wastewater and recycling it to reduce our increasing reliance on our river systems, our lakes, and so on. And that way we can tackle the scarcity of water problem, water crisis, as well as we will be able to tackle the environmental impacts. So with that, in today's presentation, I will be mainly focusing really on industrial and municipal waste treatment. And I will be sharing some ideas with you. Agricultural is another completely different scenario, which I'm not going to really talk anything about in today's discussion. So what I'm showing here is a kind of a wastewater treatment cycle. So it could be applied either for industrial or municipal uses. So any industrial or municipal users would generate some wastewater stream, which normally in most of the cases, unfortunately, goes into the drainage system, but one could treat that wastewater stream, and there will be mainly 3 standard kind of settings or systems, subsystems that would be used for treating such wastewater. So there will be some kind of a pre or preliminary treatment, some kind of screening, flocculation, coagulation, or some kind of filtration. Then if that wastewater stream has got some biological contaminants that need some biological treatments, so there will be some secondary biological treatment. And then beyond that, there will be a tertiary treatment, which either could be nanofiltration, RO, MED, MVRs, and so on. Now, one could do that, and then we would still have some reject from those systems. So these conventional water treatment technologies, they always generate some reject water. There will be some of this wastewater which is normally drained into or goes into the drain, would get recycled, and there will be some top-up water coming from the utilities, but there will be a problem of the reject. And that would then mean we have to further consider how to handle that reject and go towards very low liquid discharge or zero liquid discharge. Now, to apply such a system in industrial or municipal setting, what needs is first is a capital cost for the equipment, but then in addition to the capital cost, there is a continuous operational cost or in terms of energy mainly. So there's energy requirement, electrical energy mainly for pumping and moving of the fluid in the primary and secondary treatments. And in the tertiary treatment, there will be electrical energy at the same time in some of these processes like MAD, MSF, and so on. There will be a membrane distillation, thermal energy requirement. And that becomes a bigger challenge. Not as a challenge in terms of a technological challenge, but the technology exists for each one of these energy needs. Is just combining those technologies into the water treatment technologies and doing some demonstrations and building some confidence in these systems and bringing the overall cost down. At present, the water which is available from the utilities, which comes from our rivers and lakes, is quite cheap. It's available at so low cost that from business point of view, from financial point of view, a lot of times it does not make very great sense to the industry to use these kind of treatment facilities. So, but then the environmental factor needs to be brought into consideration. And so rather than just looking at financial benefits, a triple bottom line kind of approach should be applied in such a scenario. So if we want to take this further to a zero liquid discharge or very low liquid discharge, then we'll have to apply some more technologies, some more water treatment technologies at that last point. And that will also then need electrical and thermal energy that needs to be supplied there. So what I'm going to share with this is an example of a mining facility. And mining is a big consumer of water, and it's a big producer of wastewater. And this is an example of a tailings, so like solution minings. A lot of minerals are extracted through solution mining techniques, or also there's a lot of wastewater that is also generated through coal bed methane or coal seam gas. Either of, I mean, they're exactly the same technologies, but it generates lots of brackish water. So these are some pictures of some of these tailing dams. What they do, coal seam gas mining produces large amount of brackish water, wastewater, and which cannot be really discarded into our waterways, river systems, and so on before they are treated. And the treatment of such water can be very expensive exercise. And a lot of times mining industries, what they prefer to do is store the water in large dams or lakes and let it evaporate. And a lot of times then rainwater prevents it from complete evaporation. There's some leaching into the ground and so on and so forth. So treatment of these wastewater from mining can be useful sometimes in terms of preventing environmental damage, as well as also we can have some resource development or resource recovery from these waterways. So another in addition to these coal seam facilities, there are a lot of other mining operations where mines use solution mining. So they use water to remove minerals from the ground in form of solutions, and then those solutions are then removed in number of precipitation stages. And then along with that, there's still a large volume of brackish water that is produced, because if the mine is producing, main focus is if it's a potash mine, after producing potassium, then the rest of the water will still have large volume or large quantities of sodium chloride left in it. And usually there will be, all of that wastewater will be left in these kind of dams. So such brackish water can then be maybe treated using number of further post-treatment after the main mineral has been removed in form of some other additional precipitation system. So we could remove calcium, magnesium, and then one could use an RO to produce treated water, which can be reused in mining operation. And then the reject water, which would have the leftovers sodium chloride, can then further be treated using some thermal distillation or membrane distillation technique. Then another example would be a dairy industry, and dairy industry usually produces quite significant amount of wastewater. Mainly that comes from a lot of it comes from washing process. So when they are in between the batches, in between while treating the milk or producing cheese or butter and so on, the utensils, they get cleaned, and all of that water, which has got lots of fatty acids in it, and sometimes suspended solids, all of that gets thrown out. There is a preliminary or primary treatment most of the times that is applied, but then the water is beyond that point discarded. But that water can be further treated and recycled into the industry. But the challenge is, or that the present limitation is the capital cost and the ongoing operational cost. A similar thing can be done for on-site municipal grey water treatment facilities. So there's also lots of municipal wastewater that is generated. So that's an example of a schematic of an idea where gray water can be treated on site. There has been a lot of push around Australia for grey water use in gardens, and a lot of areas around Australia, they use grey water in gardens and parks and so on. But there's a lot of households that have got rooftop solar and solar PV and solar thermal systems installed. And during the daytime, a lot of this solar PV power, that is solar electrical power that is getting generated, is not utilized, and which is normally getting pumped into the grid, but it's not utilized. The main reason being most of the houses, neighboring houses, they are also generating their own solar electrical power, and all of that energy which goes into the grid is not necessarily used quite efficiently on around the same local kind of power network. Because there might not be industries around which heavily rely on which have high electrical demand. So in such a case, it would be a very wise idea, or very good idea, to utilize the electrical energy, solar electrical energy or solar thermal energy, which is generated on site, to treat the gray water which is generated on site. So that gray water can be, maybe it's collected in a tank overnight. So the previous day's gray water, a batch of gray water can be treated the following day and so on. So it will be a kind of a batch process, but it can reduce the mains water supply. So that's an idea as well. Similarly, because of the increasing water demands and a lot of places with scarcity of water, especially in Australia with lack of fresh water, we have got lots of desalination plants. So we heavily rely on seawater desalination, but there are regions within Australia which are salt affected, and the groundwater is very saline. So northwest of Melbourne, about 200 kilometers northwest of Melbourne, in the region close to Bendigo and around there, the groundwater salinity is in some regions is as high as seawater. It varies between 1% salt to up to 2.8% salt in that range. And that kind of limits the use of the groundwater for farming. No one can use that water for farming, for industry, for drinking, and so on. So water treatment facilities or some kind of a water treatment is used by local communities if they don't have access to town water, if they don't have access to fresh water through irrigation systems and so on. And most of the times, either seawater or saline groundwater, when treated, after treatment, the reject is either pumped back to the sea or back to the ground. And that can become a big environmental problem. And there's a large volume of that reject water that is getting dumped back into the sea or into the ground, because the permeate, no matter what kind of water treatment system you use, the permeate is limited between 40 to 60%. So there's also energy requirement for pre-treatment or these main treatments and post-treatment. And that environmental concerns are there that then can be reduced by further treating this reject using some further thermal treatment technologies such as membrane distillation. So in the previous presentations, the last weeks and the week before that, number of different technologies were discussed, were introduced by the previous presenters, and those technologies can be quite well applied in this particular situation. Further, then there's also a limit to how much water can be extracted. As the reject gets close to the saturation point, there are some practical operational issues around use of membrane technologies, use of even multi-stage flash, multi-effect distillation, and so on, because of fouling. And so then the final kind of step will be resource recovery using some kind of an crystallization solid recovery technology. And that could be this resource recovery could be through evaporation ponds or solar pans and so on. So till now, what I have explained is we need electrical and solar energy a lot, or thermal energy for these kind of systems. So what can how can we get those? We can get electrical energy from solar PVs. Thermal energy can come from either evacuated tube collectors or concentrating kind of trough collectors, or thermal energy can also come in form of waste heat from the industry. A lot of industries, they produce lots of waste heat. So they can, if efficiently used, the ongoing operational cost can be minimized. Now, what I'm going to introduce is an unconventional method which we use, which is of solar thermal, an unconventional solar thermal collector, which is called solar ponds. Some of you might be aware of solar ponds. We use them a lot with our industry partners, which are mining operations, and it's very suitable for mining operation. Solar ponds are not that suitable for farms, for example, dairy industry, or any other kind of industrial setting which needs water treatment, unless they have access to large space, land, and which is already which is far away from farming community, really, because solar ponds are based on salinity grading. They work on salt water. So let me explain what are solar ponds. I know I'm running out of time, so beyond that, I'm going to run through some of these quite quickly. Solar ponds are made out of 3 layers. There's upper convective layer, non-convective layer, and low convective layer. And so the non-convective, there's an increase in salinity gradient. So salt salinity increases as you go deeper, which prevents any convection. And hence the temperature of the bottom is higher as compared to the top. And as the sunlight enters, solar energy enters, it's trapped inside. So we have got an experimental solar pond at RMIT, and the heat which is stored inside is extracted using in-pond heat exchangers at this experimental solar pond, but we can also use external heat exchangers as well. So that's the RMIT Renewable Energy Care Facility, and these are 2 operational research solar ponds, the only 2 operational research solar ponds in the Southern Hemisphere, and we have got some evaporation ponds. So applications, we have applied solar ponds in industrial setting, in mining settings at a number of places. One of them has been solar pond in Granada. It's a collaboration between RMIT, University Polytechnic Catalonia, and Solvay. And so they use that. This is a solar pond in Spain, which was built in collaboration with RMIT. We designed it and we helped them construct and monitor it. And at present, the heat from here, from these solar ponds, is being used in their mining operation for doing drying and crystallization of some of their products. There's another example of that industrial solar pond, which is in Australia. That's in Pyramid Hills, which is northwest of Melbourne. As I said, that area is quite salt affected. A lot of land is barren. You can't grow a lot of crop in there. The reason being the groundwater is very salty. And what they do, they produce salt, different types of salts. At present, they have got solar panels of 300 kilowatts installed on their facility, and they have got a solar pond for supplying heat. So they have got this dryer, salt dryer. So after the salt solution or the mining solution has gone through a number of stages, extracted different precipitants, then it goes through the dryer. Part of the dryer, a part of the heat is supplied using at present still natural gas. You can see a big bottle, but then part of the heat has been supplied in the past by solar pond as well, and that's the heap of salt. And what they produce is high quality flake salt. So that's the process, different stages of precipitation. And then at present, this brackish water directly goes into the evaporation ponds and then into the salt dryer, but it could go into a RO system and membrane distillation. And what we have done, we have tried that at our RMIT facility on a research kind of basis. So that's what we have done at RMIT using solar pond, using salt water. So salt water is heated inside the solar pond and then goes through a direct contact membrane distillation system from the feed side, and the permeate is cooled down by the top layer of the solar pond, which is cooler than the bottom. So this particular Dcmd system looks like that. What we have, I'm showing here is a flat pack, and that's the experimental setup of the flat pack, and that's the experimental view. And we also have a spiral, commercial spiral Dcmd system, and we have got evaporation ponds. And that's the actual setup at Bandura, at RMIT Melbourne Bandura campus. And so far, these are the results. That's what we have got. I'm happy to go through them later on because I know I'm running out of time. I will skip through this. That's another example of a textile industry that has been in operation in India. And this is courtesy of Professor Jaga, who has got a publication about this particular operation. There are a number of different sustainable desalination techniques, which have published a lot of papers on there. So one of them is operating an RO using thermal energy. It could be solar thermal or industrial waste heat. So there's no need of electrical energy to run RO in that case, but that is only for low salinity water. So in brackish kind of range, in the low salinity range. This is a commercial Dcmd spiral wound. The cost of the module, that module is about $6,000, and the whole system about $11,000, and can produce about 10 cubic meters of treated water every day. You can combine power generation and freshwater production together using this combined desalination and power system concept. Happy to share publications. That's the publication where we have shared our experimental results. And that's our experimental setups. And these are some experimental results. And so thank you very much for listening to my presentation. Now, I know towards the end, I've skipped through some of the slides just because of the time restrictions. Thank you very much.
Thank you very much, Professor Dave, for your very interesting and informative presentation. I'm sure our participant will have a lot of questions, problems to clarify regarding your presentation. So I kindly request the participant to send your queries regarding the presentation through the chat box so that we can take them up during the panel discussion. The Professor Dave's presentation was basically focusing on the dealing with the energy requirement for this wastewater treatment, because one of the costs associated with wastewater treatment, especially these new techniques that we have, like membrane, the energy consumption is an issue. And also, he also mentioned another issue actually, because now at present, the price that we pay for water does not include actually its environmental cost. Okay, so as a result, actually, the introduction of these new technologies has a kind of, they face some barriers. So I think if actually we can adapt this kind of solution using renewable energy to meet the energy demand required for wastewater treatment, and that will be an attractive option for our industry. Thank you very much again, Professor Dave. So now we will move on to the next presentation in this webinar. So our next presenter is Dr. Asela Kulatunga. He is from our own university. So he is going to talk about clean production as wastewater saving option, mainly based on his experience with working with Sri Lankan industries. So if I am to introduce Dr. Kulatunga. Dr. Kulatunga is a senior lecturer and the head of the Department of Manufacturing and Industrial Engineering at University of Faculty of Engineering, University of Peradeniya. And he earned his bachelor's in production engineering from the same university, University of Peradeniya, Sri Lanka, and his PhD in industrial engineering from the University of Technology, Sydney, Australia. Then he has published several books, book chapters, and more than 80 journal and conference publications in the areas of sustainability. So Dr. Kulatunga has served in many local and international forums, which include the Ministries of Environment, Industries and Agriculture in Sri Lanka, UNEP LCA Initiative, USA, and so on. So he is the first to introduce sustainable manufacturing to Sri Lankan education system, higher university education system. And he serves as the president of the Industrial Engineering and Operations Management Society in Sri Lanka chapter, and president of Chartered Institute of Logistics and Transportation, Central chapter. Dr. Kulatunga has won the Best Green Professionals Award awarded by the Green Building Council of Sri Lanka in 2020. So it's my pleasure to invite Dr. Kulatunga to make his presentation.
Thank you very much, Professor Parakrama Karnatha, for detailed introduction on me. So before I start my webinar, I would like to thank all the organizers of this webinar series for inviting me to share some of our work we used to do in local industry for some time. But however, before I start with whatever the work we were involved in local industry, I would like to share some of the basics of cleaner production for the benefit of the participants before I go into the details of the case studies. So when it comes to the today's theme, I think I am basically cover the cleaner production point of view. Already Dr. Abhijit covered from zero discharge of wastewater point of view. So when it comes to the water management in industry, there are a lot of complications, as many of you are aware. We have to deal with many challenges when it comes to the industry water management. So we have to deal with technologies, the regulations, and then we have to work with different partners, parties, and then a lot of actors are there. So therefore, we have to handle this in a kind of a systematic way. Otherwise, a lot of complications can come, and even it can lead to some of the social pressure, social protest, things like that. Even sometimes local politics also really matters in this kind of instance. I think many of you are aware in local context what we have been experiencing over the years when it comes to the industrial water issues or industrial wastewater related matters. So in my presentation, I would like to cover these areas. So basically, I'll give a quick introduction to CP concept and how it evolves, and then how it can be used as a continuous improvement strategy, mainly because when it comes to the manufacturing or process industries, we always talks about continuous improvement. So therefore, CP can be also used as a continuous improvement strategy. So we'll talk about it a bit. And then water as a resources and its hidden cost. I think already the previous speakers as well as moderator already mentioned about this issue. So I'll show some figures only on this matter, and then especially on the Sri Lankan context. And then I'll talk about the water saving options and technologies at the point of view, especially because that is one of the key things we are trying to promote through CP. And then I'll talk a few cases of industry where we involved in when it comes to the water saving, and then a bit about the global scenario as well as this new dimension of water, mainly by taken into account circular economic principles. So when it comes to the evolution, I think maybe many of you are aware that initially at the initial stages of industrial revolution, even up to the post-war era, nobody really worried about the environmental conservation or environmental management when it comes to the industry. So always industries used to do their role without pinpointing or without concentrating on the environmental damage they used to do at that time. But later on, especially in 1960s, 80s, etc., industry tends to move towards dilution options as a measure for the environment pollution, and then started thinking about end of pipe treatment. Wastewater treatment came into picture. But in 1990s, after realizing that this end of pipe treatment also not good enough to handle this environmental pollution or damages which caused by the industry especially, this new concept called cleaner production technique came into picture, so that it basically tries to attend to this issue as an integrated approach. So this was given a momentum by UNIDO, so United Nations Industrial Organization, and they have even set up cleaner production centers all around the world, and one of these centers was established in Sri Lanka. So today we have the founding CEO of this cleaner production center in the panelist. So I hope that you will be able to get something about these initial projects they have done also during the discussion session. So cleaner production came into the limelight in 1990s, and afterwards it got momentum and then started even to go some steps further, and now it is called as resource efficient cleaner production, which will talk about more resource efficiency techniques, etc. In general. So this is how it started, given initially a no pollution situation, and then it is switched to the dilution and dispersion situations, and after that end of pipe treatment, and now we are talking about the proactive measure, that is cleaner production strategy. So if you look at where cleaner production is stand when it comes to the industrial environment management, actually it's high up in the ladder when you consider some of the other techniques which is already been popular among the industrialists or many other entities. So cleaner production basically looks into the most of the overall situation in within the company or organization, and which will try to address not only the waste one stream, but all the waste streams when it comes to the intervention. So therefore, it has a kind of a higher level of contribution towards environmental management, and it's next to the industrial ecology, which is even go one step beyond the cleaner production technique. So if you look at the definition, so cleaner production is the continuous application of an integrated and preventive and environmental strategy towards processes, products, and services in order to increase the overall efficiency and reduce damages, risk, and human and the environment. So it's an integrated preventive approach or strategy, mainly not only limiting to processes, but it can even extend it to the products and services or even systems, so that which will give an holistic approach to mitigate some of the risks experienced by the humans or the environment. So so it's an environmental strategy by taking into account continuous preventive and integrated aspects into it, and it can be applied for processes, products, and services, and can go up to the risk mitigation, not only for the humans, but even for environment as a whole. Now, when it comes to the cleaner production, there are three main benefits you will be able to do once you implement or once you go into this technology. So basically, you have to start with the CP assessment. Then it will give you an options, what kind of CP options available for you to move forward. Then when you implement CP options, then you will be able to minimize the waste streams or waste stages which are happening, not only the wastewater stream, but even the other waste streams as well. So when you have less waste streams, then you will be able to go for higher productivity levels in terms of processes. So basically, cleaner production is organized around 7 points. So if you look at these quickly, CP adds value to the environment management systems, and it's basically pollution prevention method than pollution control. So CP does not deny or impede growth, because it's support the sustainable development of sustainable growth of an organization. And CP is not limiting only to manufacturing industries, as it can be applied even for service sector as well. So therefore, there are some advantages when it comes to the resource efficiency requirement of service sector. So CP includes safety and protection of health, as well as emphasize on risk reduction, and improves immediate efficiency as well as long-term efficacy, etc. So CP basically we can consider as a win-win factor, because it's beneficial for all the parties. We can consider not only the organization, not only the society, but planet as a whole. We can consider everybody is going to get something beneficial out of implementing this technique. So what are the benefits for the industries? Basically, CP improves the products and services, and then it lowers the risk, and then it improves the image of the company, because if you are following good environment management practices, it will give kind of a positive image about you as a company organization. And CP improves workers' health and safety conditions, and then CP reduces waste treatment as well as disposal cost, and then it can be integrated with EMS, as well as it saves cost of raw material, energy and water, and then it makes companies more profitable and competitive, and it links with some of the other implementation stages of environment management practices and MEA. So when it comes to the tools, there are two main or three main approaches we can adopt it when we are trying to implement CP tools. One is basically think of the source reduction. We have a lot of practices or things we used to have in the when we try to do in the implementation stages. Or if you cannot handle it source reduction option, then you can go for recycling options. Then there will be some options available there as well. And then there's another opportunity that is basically you can think of modifying the product so that you will be able to minimize the resource consumption, including the water at different stages of the life cycle. So if you concentrate on the source reduction, there are many things starting from very basic things like housekeeping, and then even you can go into the process changes where you can think of raw material change, you can think of better process control when it comes to the resource consumption. And then you can even think of equipment modification, major, minor, and major modifications you can do to the existing one without much investment. And if it is not going to work out, if it is not adequate, then you can even think of going for technological changes where you can have efficient resource consumption there. When it comes to the recycling, you can think of on-site reuse and recovery measures. Yeah, you can have even end-of-life treatment here. And then creation of useful byproducts. You can go for that, and then even you can connect this to industrial symbiosis like concepts also. The last option available is a bit time taken one, and you need a lot of analysis, that is basically to do the product modifications, etc. So that is also there when it comes to the options or tools available once you do the CP audit, etc. So this is the methodology basically when it comes to the CP audit. So you have to follow certain stages. So it starts with planning, and you need to get a lot of support from top management mainly to get this done. And then in the second stage, you have to carry out this assessment where you have to consider about the sources of waste streams, and you have to do analysis to get why those are generating, and then you have to go for possible options available to mitigate them or to prevent them. So at the third stage, you have to do the feasibility analysis in order to go for implementation. So yeah, you have to think about the technical, environmental, and economic feasibility, and then select out of them the best options available. And at the last stage, that is about the implementation, where you have to think about the options of implementation and monitoring and evaluation, and how to sustain and continue. Because in CP, always the sustain and continuity is always promoted. You can't just apply and then get away with it, because you have to look after that process or the way you have handled it, and then continue the process in long run. So once you implement, then it will be directly linked with the environment management system, and it will have sustenance within the organization, and successfully we will be able to continue it over the years. So the other advantage we have when it comes to the CP is basically we can consider it as a Kaizen or continuous improvement to the organization. So this slide gives how it could be done. So basically you can start with CP technology, and then this concept, the 4-step method I have mentioned, then it will be linked to the company's environment management system or the policy. Then you can do further planning, and then you can even go for further implementation and operationalization. And then finally, once it is being implemented, you can think of you can revisit to the implementation, and then you can check and do some corrective actions during the monitoring and measurements, and even if there are any issues with respect to the non-conformance, etc. So likewise, you can continually monitor and control whatever the parameters, the options you have already implemented, and accordingly you can do the further improvements, and then you can do management review, and then again you can go for further continuous improvement options in this direction. Now, when it comes to the value of water or industrial water, basically, that's a big mismatch. I think already our moderator as well as the previous presenter mentioned about this mismatch. So we are actually not paying true cost for the water, especially the treated water we get, whatever, not only in Sri Lanka, but in global context, it's common, because treatment cost as well as the wastewater related treatment cost, when you compare, there are mismatches all around the world. Cost reduction, cost difference when it comes to the revenue collection. So already, according to this study, actually they have realized about 30% is only charged out of the expenses they incurred for the water treatment as a whole for all sectors, based on the tariffs implemented there. So therefore, we can see that there's a hidden cost in it. Actually, we are somehow, although we are not paying for the water bill, but that will be counted in a different way as a society. So we have to identify, therefore we have to not think just as abundant resources where we pay a little bit of money for our requirement, but we have to consider its true environmental cost and operate the other cost components, and then we should be able to think preventive measures when it comes to the domestic or industrial context. So in CEP, basically, out of this 3R concept mainly promotes, as I said at the beginning, at the point of consumption related reduction. So we promote always reduction the first instance. So that is also by taken into account at the point of consumption. So these are some of the generally available efficiency techniques, mainly by going for the water efficient fixtures, irrespective of, so some of these things actually applicable for both sectors, domestic as well as industrial context. So when it comes to the industrial context, most of these techniques are related to the facility systems, because basically for personal requirements and some of the common facilities, we can still go for these options. And this is when we do audits and etc., we found out that there are plenty of room for improvement in these general facility areas as well, when it comes to the water efficiency. So still some of the industries actually not gone into the water efficient techniques because they are not really worried about the cost. At the moment, it is getting kind of a moderate level pricing. So that may be one of the reasons, because some of these changes actually you need reasonable investment. So there are significant reductions you can see now you can do by improving even these basic facilities. So if you look at some of these comparisons, basically you will be able to recognize that from the traditional fittings to the modern concepts like we are electromagnetically operated devices, you will be able to save a lot of water when even we consider about the water closets, etc. So if you look at the industrial water saving options available, there are short-term, medium-term, and long-term options. Usually we will be able to recommend. So most of the things, when it comes to short-term, I think many can recognize easily if you pay special attention to this resource. So some of these things are very common to the many of us, even laymen can recommend these things. But these are also sometimes we realize not being done, especially when it comes to the leaks, when it comes to the overflowing, when it comes to the some of these repair maintenance requirements, those are ignored most of the time because those are not very important resources when it comes to the industry. But on the other side, what we have recognized, especially when we analyze or doing these audits, actually, there are plenty of things you can do when it comes to the behavioral aspect, especially on soft technologies, we used to say. So behavioral changes of certain categories of employees who are directly involved with these resources is one of the key things, because most of the time at the moment, many industries are not especially paying attention to this as a main resource consumption and accordingly dealt when it comes to the workers' performance. So therefore, there are some gaps available, and easily if you monitor whether things are happening in the proper way or not, then you should be able to prevent significant amounts from at the point of use. And sometimes you have to go for some modifications of the current practices, because with the traditional way of consuming these things for the industrial requirements, especially when it comes to the cleaning, floor cleaning, or even the devices cleaning or changeover related cleaning, etc., there are a lot of inefficient methods currently being practiced. So one of the best things you can implement in the industrial context is, now when we inquire about these situations, when we do the audits, basically we have found out that there are no proper way of doing things. No proper instructions are given sometimes. So sometimes there are some standard operating procedures. However, even those were defined just for the sake of doing these things in a step-by-step manner, but not paying attention towards the water efficiency related aspects, right? So standard operating procedures or even to standard work instructions are somewhat important when it comes to the water incentive activities or unit processes in the manufacturing main process. And other most important thing is, unless you monitor, you won't be able to control this consumption. It is applicable for any resource. So therefore, you should have proper monitoring mechanism or surveillance system when it comes to the consumption, especially if you wanted to recognize whether your workers or operators are handling these resources in an effective way. One of the things you can do is you can check the way they do the activities through available surveillance systems, right? So therefore, that is also one of the key things you should do in order to verify whether they are doing the activities they are supposed to do according to the SOPs, which concentrate on even the resource efficiency or water efficiency, and even the maintenance activities also need to be addressed along with these soft technologies as well. Now the other one is all about the water audits, which can be done on a regular basis than just having the surveillance. The medium-term options when it comes to the general industrial context also applicable here. That is basically go for some of these changes, mainly invest on certain water efficient equipment, then devices when it comes to the general facilities, as well as some of the what you call industry specific water efficient process related technology. So therefore, I am not going to give some industry specific applications here as a separate technologies, but that is one of the areas where you can think of going for some investment related options. Mainly it can be for the general areas like IR sensor based water closets and sinks, etc., wash basins, and then on the other side dual flushing systems, and then IoT based water monitoring and controlling, things like that. So those are some of the useful things. When it comes to the medium term measures, basically you need to have some investment here for these options. Some of the other medium term options includes adaptation of digital visualization or inspection techniques for cleaning, then usage of pressurized and pneumatic water mix cleaning for general cleaning, as well as specific cleanings of the vessels and containers, as well as flow. And then modify devices to improve the water efficiency. It's depend on the process, depend on the machinery. You have to go for some improvements. Basically, you can go for various water sprinkler systems for cleaning, then pressurized water supplies for cleaning, then having a warm water for cleaning or things like that, so that your amount of water being used, fresh water being used, can be controlled. And most important thing when it comes to water efficiency is to go for sub metering, so that you will be able to save a lot of, you will be able to quantify first on section wise or unit process wise consumption. So therefore, that will be really useful for you to go for next option, that is to decide what are the hotspots when it comes to the water consumption and how you could prevent them or minimize them, or what kind of interventions are required. Then next one is basically to convert appliances or fittings to water efficient models or models, the new versions of it, because there are always, when it comes to the equipment manufacturers, they always consider about resource efficiency, because in developed societies, they are really concerned about this resource efficiency, not only for the domestic environment, even for the industry is concerned. So therefore, you can think about latest versions of the equipment when it comes to the process as well as the general usage. Then you can go for those options if you have adequate investments. And then IR sensor-based techniques, mainly for general purpose water closets and wash basin, things like that, and dual flushing systems, etc., can be taken as midterm. There are certain investments are there. But when it comes to the long-term measures, basically, you can think of further investments when it comes to the water. Basically, you can think about rainwater harvesting and having separate systems to use them for the sanitary requirement after treating. And then you can go for water efficient devices. You can think about water rating and then star ratings, etc. And accordingly, you can select the items. And even when it comes to the industrial context, you can consider about the specially coated vessels, so that there won't be much requirement for the cleaning after each cycles or each batch changes, etc., etc. Especially for that, actually, you can use nano coating materials, etc. And then again, you can concentrate on green building concept, which will again give special attention towards water efficiency side as well. Okay, now let's look at some of the experiences we had in local manufacturing sector, especially. So we have been involved with many manufacturing sectors when it comes to the process improvements, especially on ceramic, tile, and various other industries which are available. So basically, we used to do basic process plan when it comes to the overall improvements, process improvement with respect to the resources by taken into CP options as well. So basically, we used to do, when it comes to the water efficiency, we used to do water audit initially, and then concentrate on the manufacturing processes as well as the facility areas. Then you had to do some unit process related analysis, and then you had to go for further analysis on the different activities which are happening at each and every unit processes, and then you can do the measurements as well as you can study some of the existing practices when it comes to the behavioral aspects, and then you can analyze and then propose some of the standard options available there with some feasibility study. And when it comes to the general facility areas, basically you have to identify the types and then the frequency of usage, and then you have to concentrate on the patterns of usage. Up to a certain extent this is possible because you can't do some of these observations in general areas when it comes to personal requirements. So therefore you can guess by having some measurements and then by observing some of these places. And when it comes to the water auditing, basically you have to concentrate on the product changeover, especially for the manufacturing and process industries, because every changeover you have to clean these vessels, and then the plant up to a certain extent in order to maintain the hygiene side of it. And then then you have to concentrate on the volumes by doing some quantifications, and again you can do some studies on the existing practices, and then you can do some what do you call recordings and audit the results, etc., analysis, etc. So basically, most of the time, what we have realized when it goes to the industry, we can see most of the industries, they do not have proper mapping of this water, especially water distribution, water consumption, and where these are, how those are connected, etc., etc. So sometimes we have to go for even the level of mapping those distributions, things like that, before we go into the audit. So these are some of the audits we carried out in unit process basis for certain industry. So we have to consider now in this assessment, actually we concentrate on all the resources. So therefore, not only water, we have to consider about other aspects as well. And then even we can consider up to the unit process level, and then we can do some benchmark studies or comparisons, etc. And then we can propose some options available. So some of the options I quickly go through. These are basically based on one particular industry where we have noticed significant water consumption taken place mainly for the cleaning cycle. So we have came up with short-term, medium-term, and long-term solutions. Short-term basically even linked to some of these less investment or lower hanging fruits when it comes to the CP options, and then medium-term basically requires reasonable investment, but still those can give some promising results. Long-term one are big R&D related ones as well. So these significant investment, and sometimes certain lab analysis also was supposed to be carried out. So likewise, there are significant changes you can expect by going for these kind of measures. So these are some of the figures for some case studies, and then some of the long-term options we suggested as a switching from one cleaning method to another mode, so that you can save about significantly water consumption, about 50%, by switching from chlorinated cleaning to the ozone sanitation methods, and then even for going for non-stick coating methods, things like that with nano materials. And then by doing that, reasonable percentages basically can be saved in these options. And there's another thing actually we have identified when we do this one of these long-term research. Actually, if you can go for further, regular monitoring of these resource consumptions, basically by the adaptation of IoT platforms, it can be connected to product design and development, as I mentioned in the initial state, as one of the options. Although it takes long time, but still you can do it. And this is one of the frameworks we have developed in that respect, not only for the water, but even for other resources. Ultimately, it will be end up with product life cycle management, where we have taken into account product design and development stages and how these inputs can be useful for the design and development, or to take relevant decisions at the different stages of the life cycle management and product design. So this is basically configurations we have came up for the IoT platforms to tap the unit process related resource consumption. And this is a schematic diagram of the overall framework we have developed. And this is again, I don't need to cover, because already water footprint, global water footprint related matters already covered by the moderator as well as the first speaker. So you can see now even we are in an alarming stage when it comes to the Western province and especially the dry zone of Sri Lanka. When it comes to the water footprint situation, because we are consuming significant amounts at the moment, though we have enough resources as a country. So even though at the moment agricultural products are consuming a lot of water, but industrial or processes also we have to pay special attention, because that can contribute a lot with the rapid customer requirements and rapid needs of the consumers. So some of the agricultural products also involved with industrial processes. So therefore, if you look at the product wise water footprint, still there is a portion played by the industry. Although this analysis, this agriculture consume more, but when it comes to the industries, especially during the processes or manufacturing stages, there are significant portion comes there. So therefore, if you look at the overall water footprint of some of these process products, especially food items, still you can see significant water footprint. But even that significant part goes to the initial stages of these products, but manufacturing and processing part also consumes a lot, because in order to maintain the hygiene, in order to maintain the cleanliness, we have to consume a lot of water. So finally, I would like to end up my presentation with this new idea. Actually, this has been developed by one of the Europe group called Suschem organization. where they have taken into account this overall water as a resources, and where all these resources can be extracted, and how we can further refine, reuse, and then reuse, and again go for multiple cycle of usage, mainly by adapting the what we call circular economic policies. Circular economic policies is been already promoted by UNEP especially, and now it's being extensively used in European continent, and it is slowly coming with various projects to the even Sri Lanka and developing countries. I think with the development of especially these new technologies, we should be able to monitor and control and go for this kind of a concept in future. And with that idea, so there are many things have been already done in the research domain, especially to adopt Industry 4.0 and data analytics for continuous monitoring and analyzing, and then take preventive strategies for these resources. And ultimately, if you adapted this technology, especially for continuous monitoring, analysis, and take necessary actions, then you should be able to go for actually it will help basically for the SDGs we are directly involved. So with that, I would like to wind up my speech. So I would like to thank all the participants, panelists, and the organizers, as well as the moderator. Thank you.
Thank you very much, Dr. Asela, for your very informative presentation, which actually also covered the fundamentals of cleaner production. And I think some of the participants will find it very useful, especially if you are not kind of familiar with the concept of cleaner production. Then also actually you very nicely covered different stages of this implementation, because I think when you are like entering into the cleaner production as an industry, most of the time actually the solutions are very simple, like maybe simple housekeeping changes, maybe behavioral changes, and so on, what you mentioned, and the soft technologies and so on, and then medium to long-term solutions. So in that sense, I think it was a very comprehensive presentation. So we will now move on to the panel discussion. So let me introduce our additional panel members in addition to the presenters, two presenters. So we have two eminent panel members. One, of course, is no stranger to the academic circles, Professor Jega Igathisan, because he has a lot of collaborative works across the globe. So Professor Jegathisan is the professor of environmental engineering and also director of Water Effective Technologies and Tools Research Center in School of Engineering, RMIT University, Australia. Then also we have for Sri Lankans, especially industrial people, and then also who are working in clean production, Mr. Sena Piris, who is no stranger. He was the former CEO of the National Clean Production Center, Sri Lanka, and actually he played a major role, a pioneering role in introducing cleaner production to Sri Lanka. Not only cleaner production, but other concepts like even life cycle. I remember maybe late 90s he introduced. Long ago, then other industries came into take this concept in, and then also things like chemical leasing, eco-innovation, and so on. Let me welcome you all, the panelists, for this session. Then in addition to that, I think also Dr. Verago will be available if there are any relevant questions. So again, participant, if you have any questions related to the topics that we covered today, you can send them through the chat box, and then we will move on to the questions posted by the members. Okay, I'll start with the questions sent by the members. So some of the questions I think they have already answered, because there is a time limitations because we are kind of beyond the scheduled time. So we'll take some of the questions. Now, first question is to Professor Abhijit. So the question is for small scale brackish water treatment, can your system be applied?
Yes, definitely for small scale and brackish systems. So the general PFDs that I was showing, they could be applied almost anywhere with customization for individual site requirements. But for if you're talking about the specific one, which with solar pond, and there was a thermal pump and DCM, direct contact membrane distillation, yes, it can be applied for small scale brackish application. If I would be more than happy to answer more or help around. I'm not very sure who's asking this question specifically, but they can email me.
Yeah.
So
Okay.
I'll put my email address in the chat.
Right. Okay, then there is a question to Dr. Asela. So, which industries in Sri Lanka need immediate attention with respect to cleaner production? I think Dr. Asela and also we have Mr. Senapiris. So, from your experience, actually, you can answer this question.
I think Mr. Piris can go first because he has vast experience in the industrial context. So, please, Mr. Piris.
Thank you, Professor Parakrama. And thank you, Professor Abhijit and Dr. Asela for very comprehensive and informative presentations. In Sri Lanka, I think one of the, at the moment, we are not having so much of industrialization. But we know we have textile industry and the food industry, which are critical for economy and which consumes a lot of water. We do not have much mining, but there are the food related. When I say food related, it can be several subsectors included, from fishery, maybe agriculture, all that is included. So those two are the priorities in Sri Lanka. And especially we have to remember these agro industries are a key for actually high consumption of water. And probably this is something we have to address more immediately. And then later, probably there are other areas which we can address. In addition to that, I would like to just add a couple of things to what Dr. Asela said. We have to understand in cleaner production, we are looking mostly at the industry, but that is consumption, sustainable consumption in the industry. That's all we look at. But one important thing is we have to redesign our products in such a way that water consumption at the household level or maybe in other industries, that is the post-production water consumption also should be addressed to reduce the water usage. So if we address that, there's a significant reduction of water can be reduced from the industry as well as the industrialized consumption. Thank you.
Dr. Asela, would you like to add anything to that?
Yeah, I think Mr. Piris gave a comprehensive answer, but just to add to what Mr. Piris said, I have seen, especially in the food sector, there are a lot of significant water consumption is taken place, not only for the process, but mainly for the cleaning. Unfortunately, most of the cleaning practices, we have to depend on, rely on the treated water in order to maintain the hygienic requirements, etc. But when you look at the practices they do, those are really inefficient ways of doing it because of the prices may not that reflect the environmental burden comes with this resource.
Thank you. Maybe similar question. There are two questions, similar questions. So I will take them up at the same time, Mr. Piris. So now one question is why actually cleaner production is not kind of penetrated, if it is the case, penetrated to Sri Lankan industries. What is your thought about that one, Mr. Piris?
Right. Okay, I think that's a very valid question and very important question. Not only in Sri Lanka, all over the world, this is a question we all ask most of the time. Cleaner production is a concept which actually comes, and the waste minimization or saving of resources comes from within you. unlike EMS or ISO 14000, which is probably a market-based requirement, cleaner production is not a market-based requirement. So that is one reason the people are not yet ready to understand the implications of the resources, not only water, energy, water, and even raw materials in their daily life. Whereas EMS make it compulsory for the industries to carry on certain. This is influenced by the outside. So within our people, if we do this, and if we understand it, then we will be doing it, number one. The second thing is, there are many industries who have already applied cleaner production because it was actually thrusted upon them by the buyers, especially the export industries. Most of the foreign buyers, I would say the high class buyers, I would say, or maybe environment conscious buyers have insisted that the waste should be reduced, and they are given certain conditions and even the benchmarks. When that happens, a lot of Sri Lankan industries have already applied this. And we have to probably create benchmarks, and we have to make it mandatory so that the industries have to do it. But a lot of industries have seen by applying cleaner production, they have cut down their cost and they have improved their internal working environment. The workers are happier, safer, and then also they get additional benefits. Yeah. So therefore, the cleaner production should be actually make it mandatory like in China. China has made it mandatory. There is cleaner production law. So therefore it is happening. Unfortunately, in Sri Lanka, we don't have it. Certain countries are now making SCP mandatory, which includes cleaner production. So maybe we should think about at least let's make sustainable consumption and production mandatory, which requires cleaner production essentially.
Thank you, Ms. Pires. Maybe it's the same line. If we go to Australia now, Professor Jeka, how is your experience? How widespread cleaner production concept in industries, and also similar, same question, similar question now. How is the penetration of these technologies? Things like that you have developed in RMIT, so they kind of readily penetrate in the industry, or how is the situation?
I think, yeah, thanks for that question. I think it is the industries are becoming more aware of that one. So, of course, if you are able to show some technologies, they are willing to adapt that one. So that is there. So we are trying to introduce various things to, for example, car wash stations, whether you can reuse the water, and the textile industry, whether you can reuse the water, recover the salt. So when there are technologies, yes, they are aware and they are taking it up. And obviously, they see the benefit, like Mr. Pires mentioned. When they implement, they get really benefit. So environmental benefit there, also their business gets a lot of benefit. Therefore, they are willing to implement that. And separately, the same thing we are applying for the domestic water use also. So a lot of education is happening. A lot of water saving devices are at home, and the pressure reduction in the main distribution systems are there so that you don't get too much water and so on. So you can see the amount of water used by the industry and the domestic use in Sri Lanka looks like comparable. Okay. So I think both are valuable to, in both areas, if we can save the water, it will become meaningful. Here, maybe we use a little bit more water in the industrial sector and also maybe more agriculture. So there are a bit more water we use. So saving should happen there. But even in the domestic side, we try to save as much water as possible. I hope that answers your question.
Yes. Thank you very much. And also, like now, for example, there is a question regarding this groundwater extraction by the industry. So before coming to the Sri Lankan situation, may I know what is the kind of policy in Australia when it comes to groundwater extraction by industries? Do they have to pay for that? How is it controlled? If you have it, yeah.
I have some limited experience with groundwater areas.
Okay.
In northern Queensland, we have a lot of sugarcane industry, and they pull a lot of water. And also some coastal area, they pull a lot of water from the ground. So what happens, the sea water intrudes. So therefore, they started to impose certain limits. So you cannot pull certain amount of water, maybe certain kilometers from the sea. And the further you go inland, you can pull more water. So there are that kind of restrictions there. Serious studies have been done, and they have developed a lot of models, and then they work on that way.
Okay, all right. Thank you very much. So we will come to the Sri Lankan situation regarding the water used by industry. There was a question. I hope Dr. Veragoda is also in the panel. He is from the water board. So we will combine the question. One is actually the tariff for water. Can, for example, the industries be charged more than the domestic users? One question. The second one, the groundwater usage by the industries, because when we go to industries, we see they have a borehole and then take water from that, and they say we get water free of charge, and then because of that they are not kind of bothered to waste that one. From three colleagues from Sri Lanka, can you kind of give your thoughts on this topic? One is maybe directly to Dr. Veragoda regarding this different tariff system for industry and domestic users. Second one, the groundwater usage by industry. Dr. Veragoda, are you with us? So otherwise we can move on. Dr. Asel and Mr. Pires, what is your thought on this groundwater usage by industry?
Yeah. Can I make I think one comment regarding this tariff? I would like to say, now if we understand Sri Lankan pipe-borne water supply by the National Water Supply and Drainage Board, we are having only one particular type. Say now the people as well as the industries are using the same water for washing the floors and then washing of vehicles, and even for their gardening and also toilet flushing, everything, which is not required. Even the households, the same thing. So either we should have the two pipe system where we have potable water, which is used only for the specific purposes at a high rate, which requires higher cleaning and purification. Whereas the second quality can be mild treatment, and where you don't need the chlorination and all that, so that that water can be used for all these mundane applications. Number one, regarding the water usage in industries and the households. The second thing is about the groundwater. I believe there is no restriction at the moment, but it should we should have ground restriction, because I remember there was a plan to have restrictions. At that time, we have a protest from different segments of the society, and therefore the plan was stopped. So it was a very sensitive issue. But I believe that there should be restrictions when it comes to the industries or even to the houses. There should be restrictions, especially because of the quality of water. There can be issues with health. So I believe that the regulations should be imposed on groundwater extraction.
Okay. Thank you very much, Mr. Pires. Dr. Asela, do you have anything to add?
Yeah, basically, when it comes to the manufacturing sector, local manufacturing sector, now what I have seen is majority of these plants are actually located in river basins, mainly by taking into account this groundwater availability. So they are not dependent on pipe-borne water for the most of their requirements, because as Mr. Pires correctly said, that these regulations are not fully implemented at the moment, so that there can be some sort of advantage just for the industry out of this. So that may be one of the reasons why they are not paying that much of attention towards preserving this resource, because those are abundantly available at the moment, especially if you look at the industries located from maybe somewhere from Hangwell towards Paliagoda. Most of the industries are fully dependent on Kalani River Basin related groundwater. So even in other areas, I have seen some of the industries are located by expecting that groundwater is adequate enough, because when they pick these industrial zones, basically some of the zones which are scattered around the country, those are basically motivated by the politicians, local politicians, to set up them there without taking into account the resource availability and even handling of some of the waste streams. So therefore, at the moment, this is a serious issue, but still society is not that fully aware of this this issue. So in future, there will be significant protest and issues like that when it comes to the even dropping of groundwater table, etc., by excessive consumption of these industries by this area. So therefore, regulation should be enhanced. And then even for the tariff case, I think we have to revise definitely. I think Dr. Verakoda will tell more about it. When you look at the present tariffs, it was done long time ago. And even if you look at the industrial tariffs they have imposed at the moment, those are far below the actual cost of treating. So therefore, there should be something, as well as what Mr. Piri suggested, this dual law, multiple options of giving this resource, that would be also another innovative thinking we can think of.
Okay, thank you very much. Yeah. Dr. Asela, there is another question. I think this is regarding one of the modifications you kind of presented, this coating of nanomaterial or Teflon. Now the question is, like, for example, especially things like nanomaterial, we still probably don't know what is the kind of real health and environmental impact. So the question is, like, when you kind of go into these solutions, shouldn't we also look at the bigger picture, like what kind of other impact it can create? So what is your...
Yeah, definitely, because that's why I said there are certain options where we have to do a lot of R&D. So you can't just dump in, because those are innovative new technologies. So at the moment, certain developed countries gone for this option. So we have to rely on these options and then go for this, then just blindly take them, because at the moment, even as scientists, we can't say 100% this is perfect solution, because we have to do R&D part. There's a R&D part in it. All the industries also not going to be benefited from this, because depend on the chemicals, etc. These things can change. That is definitely there.
Okay, thank you. Then there is a kind of specific problem if the panel members, especially Professor Jeka and Professor Abhijit, if you are willing, you can answer. How to manage the sludge and reduce the bad odor during the waste treatment? Would you like to answer?
Yeah, sure.
Yeah.
I've typed into the chat, I think a similar related answer, but I don't know about the order, but definitely managing the sludge can be done if it can be looked at as a resource rather than a waste. So resource recovery, depending upon where was the original wastewater coming from. If it's an industry-based wastewater, the sludge might have some useful resources in there, and recovering them. Or if it's coming from municipal waste, can be converted to fertilizers or a fuel source. So not just dumping that sludge as a waste, and that which then leads to the bad odor and all the other environmental damages. Maybe Jaga can add.
Yeah, I think, yeah, you are right. Depending on the source of the sludge. So yeah, if it is a domestic wastewater sludge, obviously you will do the anaerobic digestion. You can produce methane gas, and then the remaining solids can become the biosolid. They can be applied for land applications. And odor control generally happens. Normally, you can actually, if you go to a wastewater treatment plant, the odor control can be done by pulling all the air and passing through some sort of adsorbent, like biofilters. They can absorb the odor and so on. So that's how you generally control odor. So those are the combinations you can have.
Yes, thank you very much. And then another question regarding this solar pond, Professor Abhijit. Now, can you use, like, for example, the rejects from the desalination in these ponds?
Yes. So solar ponds, they need a continuous supply of salt water to maintain their salinity gradient. So at present, that's what we are proposing. The reject from any desalination, which is very highly saturated reject, can be a feed or can be a resource to the solar pond to maintain its salinity gradient. Yes, it can go into the bottom of the pond.
Is there a problem of saturation of these salinities?
We want the bottom to be saturated all the time.
Okay.
And that's how it works. That's
Okay.
all upon.
Okay.
Yeah.
So I think that's it. We have, I think, covered all the questions. So it was a very productive session. But if any panel member would like to add anything, we can have some time. Okay, so if not, actually, I think we can wind up this webinar because we have spent something like 20 minutes more than our initial plan. But I think everyone will agree this was a very useful, productive session. And I hope if there are industrialists among the participants, the success will depend on how much you take from this one and then apply into the real practice because cleaner production is something probably we have to move on because as mentioned, it basically look at prevention of pollution and then also the conservation of raw material, water, energy, and so on. Because it's not going to only address the environmental issues, but definitely, as if you remember from Dr. Asela's presentation, they are going to give you economic benefits as well. Most of the time, when you calculate the payback period for some of these implementation, we were kind of surprised and double check, can you actually recover this money so quickly? But actually in practice, you will see most of the solutions, especially these short-term solutions, are very promising. So I would like to thank the two presenters, Professor Abhijit and Dr. Asela, and then also our panelists, Professor Jega and Mr. Siena Piris, for your valuable contribution and taking time to share with your experience, knowledge with us and the participants. So thank you very much and have a nice day.